Hey, what's up? Papa Bale. Got tons of stuff to do, and we're gonna start. Actually, we're gonna put the other rotor on to start. It fits perfectly. Awesome. Perfectly it fits. So we take this one off. Put it over here. I wonder if this one will float on the toroid like that one does, but we're not gonna do that. This one's a lot lighter, actually. Right. So we got some pendulum magic happening on the side here. We're going in between. So we're actually getting a little bit of BEMF off of this one. From the power, just the power supply. It's kind of lighting up a little bit. This is 25 volts, like less than 100 milliamps. Let me see. That's going really good for 2 point less than 2.5.
All right, now put the other rotor back on.
I'm gonna put the other motor back on. I'm gonna go with the light was turning on though. I want you to register that. That's important.
Right. Light was turning on.
Very small, very little bit. At 25 volts. You know what I mean? This baby is smooth.
Yeah, the U and the saucer.
UFO is smooth, but the Celtic Cross is smoother.
Smoother.
So we're gonna push it down, and we're gonna spin it. It was great. Huh. I wonder that'll work.
Bingo.
And we're getting some action in the light too. Very little bit. Not anymore. It just turned off. I don't know. I don't get why it does that. But you know, we put the transformer back in, and that thing's gonna like light up. That's 25 volts. It might work its way up to 100 milliamps before it. Yeah. Now that magnet in the middle that it's resting on, it's really cool how this rotor works with the magnet. Really neat. Really neat. It doesn't need another toroid magnet to, be buoyant. Air resting in the toroid out there. All right, so you wrap the wire around it, and then that gives you a fourth coil. that's actually thicker than the previous coil, and it's underneath the rotor. So that's another thing that you can consider. There are 4 magnets on the rotor. I'm pretty sure the way it's set up, each magnet is hitting each line of that coil every time it passes. But I mean, it's I think it's really significant. So what I'm going to do right now is I'm going to plug that green wire. I'm gonna clip this. Now the light's going on. Check it out. Oh, bright. Maybe I had something to do with that.
Mm-hmm.
I always thought that,
Your own energy.
but more like a conduit for the electricity.
Got it. That's already there. Yeah.
Uh,
Hey, everybody.
Hey, what's up, everybody? Finally got that spinning. Did it a real simple way, pendulum, uh, magnetics.
If anybody's got any questions about the setup, drop some comments. You want to run through what we got going on here?
Sure. I call it the amp funnel, and it's all about speed, kind of. I mean, it's not the fastest thing in the world, but what we do is we take a lot of amps and we put them in this coil right here, 14 gauge coil. A lot of amps can flow through that. And then here is like an 18 gauge coil, but they're all hooked in series, just a series circuit. So it's like one big long wire anyway. So when we go from this one to this one, it's like a bottleneck. The amps get forced through and like shaved off, and they generate speed, bursts of speed. Like I don't know, I don't know. I've only done this side of it yet. Um, but I'm gonna make all 26. This is a 26 gauge. I'm gonna make all 26 gauge coils and see what happens there. But it goes down to the 18 gauge or the 1 millimeter wire. And there's 90 here, there's 180 here, and there's 3,174 turns here. So it goes smaller and longer as it continues down. So I would think that those amps would be forced into speed because let me explain with power real quick. This is just the power supply. And just with the length of wire there and the size of the wires, this is what we're drawing uh, from cycled amps. This was what makes it back to the power supply. And it's increasing a little bit. Actually, it was at point zero for a while. Hold on. All right. All right. So Right now, just the power supply is hooked up, and it's feeding the series circuit, which goes boom, 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 boom. And then we have a BEMF coil, which is pretty significant to me. There's 8,888 turns in this coil. I said there was going to be 8,888 turns in the coil. And the coil, the spool that I was using to wind that coil ran out at 8,888 turns. Woo! It's like, oh my God, that's a one of those moments.
It is. That's cool.
But you know, I'm sure everybody has a moment like that occasionally.
Mm-hmm.
But these little ones here are offset. They're offset. They're not directly on the switch or this. This is like the main. It's where it all ends right here. So this is where it gets the main drive is.
Hey, everybody, if you like content like this, drop a like, subscribe, let us know where you're from.
Yeah, that's cool. Heck yeah. All right, so this is just the first part. Now, I'm gonna unhook this. Huh. That's weird how like finicky that stuff is. It was working just a second ago, wasn't it? Right. Okay. That's fine. Fine. You know why? Because I'm gonna hook this up. I have a feeling we're not gonna have any more problems. This nifty little unit here can go up to 345 volts from a 10-volt input. As far as I can tell, it turns on at 10 volts. I'm not exactly sure what it's set at right now. We can test it. You guys want to test it? We're going to test it real quick. All right. So, it's going to be 3, 2, bring it up to 10 real quick. All right. It's only 66 volts right now.
The transformer.
Yeah.
Okay.
That seems like a pretty good, decent voltage to start going above 25. We go from 25 to 66.
Oh,
Good.
that sounds good. That's
It's a big jump.
that's all right. We like big jumps.
And we're going to take a look at the wave that this series circuit makes.
Right here.
I don't know how to read the waves, but I know that the below the line symmetry is negative, basically, from where you're plugging it in. Okay, so 66 volts. Here we go. And boom.
Wow.
Yeah, everything's on. See, on, like on. And that's only at point. That's only 400 milliamps. Now, if that manages to peak itself up to 5, this will get brighter. There it goes. I'm telling you, the way I have these coils set up, it goes big to small to smaller to bigger. The last coil is bigger than the one before it, so and it's a lot shorter. So the amps are going to go up. Might even go up, there it goes, 0.6. And this is getting brighter every time that goes up. This is a 15-watt LED light bulb.
Nice work.
Not very hard to light up, but a lot harder than say a 12-volt LED or a 3.2. Those would be lit way brighter. What's up?
If anybody's got any questions, let us know. We're here to serve, and we love to learn from you guys too. So we are in Michigan in the Detroit area, and drop a comment. Let us know where you're from.
Here we go.
We got our first comment here.
Hey, what's up? It's Bo. I'm using BEMF to light up everything. These 3 coils are a drive circuit. This coil is a generator coil. So I would say it's capable of doing both.
Nice question.
Yeah, thank you.
Ben's gonna blade. I like that.
It's also permanent magnet pendulum theory. Oh, we just got a nice spike. Like, nice spike, dude. Wow. And this wave here is very erratic. But it keeps it cool, I guess, by being so negative like that. And then eventually there's occasionally a positive spike. But the main energy is negative. Let's see if it reflects that. Wow, does that say 96, 97, 100? Wow, the hertz. Oh.
Let's see if we can get a zoom on the hertz there. There we go. The numbers at the bottom. Let me try to be still here. Yeah.
102, 22.
Yep.
Wow, man, those hertz are going up.
And this is a good proof of concept for the
Amp funnel.
And even the magnetic sculpture.
Yeah, I'm gonna actually probably use this size
Okay.
amp sculpture with this size shaft. I have a bunch of these going up like a staircase.
Yeah.
But I'm gonna have like 2 stacks. So I'm gonna have one started here and one started here, and they're gonna like go like that. And they're gonna use the same pole they started on and everything.
What's up, 007?
Yeah, man, it's terrible, isn't it? Like crashes into the shore really hard. The wave is like an inverted heartbeat. That's awesome. It is. It so is. And it's the hertz are they weren't this fast. It wasn't going like that earlier today. Oh, that's probably because I didn't have the little mini thing hooked up. The other rotor. Oh wow, dude. This thing is really, really unstable.
I don't know if that's instability.
Well, I mean, it's yeah, it's chaotic power. There's like little spurts of power every once in a while.
Okay, because yeah, I've seen it with like a solid pattern before
Yeah,
too.
yeah,
Yeah.
that's what I'm trying to get at. Is when, but this is a readout for the amp funnel. All three of these coils are hooked to this meter right now in a series circuit. So it's like I hook it, or is it still hooked up that way? I don't know. I don't know. Yeah, sure. I don't even know.
Nice. So fast pulse and slow decay, but showing negative must be good. So that's the
Well, that's a good thing.
yeah. So the downward punctuations there. I think, but yeah, I don't know how to read this yet.
All right, so the negative one is hooked up to here. Wait a minute. The positive one. Oh, it's hooked up, yeah. So it goes bing, bang, boom, and then the one underneath, bam. And that's what you get from from that series on the oscilloscope.
Beautiful.
And I'm not exactly sure how um, to read what's on the meter here.
Yeah, that's
All I know is that once you put it through the transformer, it goes up in voltage. And whatever they do with all the rest of the amps, I don't know. But that's quite a few amps for pushing the 66 volts.
yeah, and you can see it's trying to push more amps through the light here.
Oh my God, dude. Wow, look at that pulse. That was almost like it being plugged into the wall, huh?
Because you can see
Yeah.
like on the recording how it's pulsing.
Right.
You can't really see that with the naked eye.
No, you can't. You can't really see it. You can kind of see it. You can see the ambient light pulsing, but you can't when you look right at it. You can't really see it pulsing. But you can see the light pulsing.
And then every once in a while, there's a bright flash in real life on this thing.
Yeah, and you can hear it.
Mm-hmm.
It's like we can get that up to that level.
That's beautiful, man. Let me get the whole thing in there. There we go.
Yeah, those little spikes.
Feel the light.
Yeah, yeah. Yeah. How's that coil coming, man? Yeah, the light is cold. Like you said the other day that the light would be cold, or like the wire would be cold, or negative one's cool.
Nice.
Sweet. Yeah. So I was gonna make more 26 gauge coils and probably blow this thing out of the water. And either add them or replace these two coils with 26 gauge coils. Same size with cores. And then I'm sure that the beat EMF would work. If they don't work on this size, they don't work on this size. Doesn't work on the 20 gauge coil. It works on a 26.
Oh wow. Epoxy every 5 layers.
Wow.
That's awesome. Dedication, intense, and I'm sure worthwhile.
Yeah, yeah, just do it right. Do it right the first time, right?
Mm-hmm.
If I even knew the right way to do it, maybe I would have done that too.
Yeah, right. Hey man, you've come a super long way in a year. Yeah, that's intense.
Is that including dry time? Or is that just winding time? You can tell this is like negative because it's like dim. It's dim. But I mean, it's radiant, but it's dim. Oh, gotcha. It's cool though. It's really neat. All right, so this is 66 volts. I've had this thing going at 100 volts. Do we want to check out a higher voltage? Nice. Heck yeah.
Yes. Yeah.
So we can make it really interesting and I can give it 3 turns. Or I could just give it a quarter twist. Try to get it up to like 70 volts. 75. It comes in the mail at 75 volts, I'm pretty sure.
We used to.
Yeah, we can grow some pretty good weed. Back a little while ago, though.
Yeah, it was a while ago.
I mean, about 10 years. I don't know. It was all right though. Should I test that?
Yeah, how many turns do you think you did?
Like 3/4.
3/4. My guess is it's at from 66 to 92.
You think I did it 3 times?
Just I don't know what each quarter turn will do on it.
I'm thinking it's gonna be around 75. Maybe 80.
Oh, that's all right. That's all right. You know, when I tried this method where we just used probiotics, so like lactobacillus, and then living soil, flavor was better. So 0 chemicals.
Yeah, it was really good.
It's lower yield, but it's way better. And sometimes it's better yield.
68.
Okay, so you know what we're talking about. You're the man. Or you're the person. Well, I mean, I don't want to do it.
Oh man, dude. Yeah, that's a guy. Huh?
Okay.
I can't see. I just need to get it from that little crap. I got it. Yeah. Alright, one more time. For the win.
Oh, you're testing. 69. So that
One
went.
volt. Oh, no, that's not good enough.
My goodness.
Not even in the crack, bro. Hey.
You're close.
I don't know if I'm close, man. I can't see. I don't feel it either. Let's see. Let's see. Maybe all that jostling got something done. Perfect.
7. Boom.
Alright.
So from 66 to 7.
I need my glasses. And I found that, like, looking at, like, medium voltage, like 75, 80, is way better than working at, like, 120, because you keep on skipping and blowing stuff up. But if you could get it to run at 120 nice and smooth, I'd go for 120 any day.
Yeah, I think, nice. That's so cool. I like that. And, yeah, when we get a workshop, we'll be getting more, sophisticated equipment for sure.
Sophisticated equipment.
Mm-hmm.
So yeah, I don't know. There's like one more thing I can do, and that's to connect the negative, and the light will go out. Light always goes out because I don't know exactly the reason why. And now that coil on the bottom has the BEMF going directly into it. And I got a Schottky diode hooked up to the positive end of the BEMF coil. So I don't know exactly how it works, but when it does its spike, it sends it right into that bottom coil.
Yeah, the railguns are an interesting concept. But he was talking something the other day about.
Oh yeah, I've seen different kinds of. That is an N52 spherical rotor type deal. Oh my god. It was like stuck on here. See that bad boy? Wow.
And then propel that or accelerate it through a coil setup.
Mean. It's mean, dude. It is so mean. So I was thinking about using this as a rotor. Is that a good idea? And everything in here is nice and chilly. I'm going to check the wire real quick. Oh, it's 0.9 amps. So do the amps go up when you got the BEMF coil plugged in?
That would be cool. An electromagnetic rail gun and a potato gun, and then we see which one. No.
So, look, man, look, the amps went up by 300 milliamps just from me plugging that negative BEMF coil into the negative of this coil. What would you call that? But still, even with those 300 milliamps, it's not compensating for the amount of loss in the system. But those, I would say that those 300 milliamps are quote unquote free.
Okay.
I mean, you got, I don't know, not really. I mean, you got to be about 30 volts to even start. I don't even know exactly how it works, honestly, because this light is really, it takes a certain amount to light this light, and I think it's about 35 volts. So this light is not a good indicator of how much electricity is flowing through that coil, because it won't even turn on until like it gets to 30 volts. So when it's nice and bright, you know that there's some energy coursing through that thing. Hydrogen powered potato gun. Yeah, I seen some of those rail guns on the Navy ships. Like a $500 million rail gun. Those things are mean. Just looking at them, it's like, wow. Yo, man, what did you name the live stream?
Do like a multi-rotor setup.
Nice.
Yeah.
That's sweet. I like how that rotor is just kind of floating there. It doesn't have a magnet underneath it. I made some like videos earlier on with just permanent magnets, and this principle is demonstrated in a lot of that work. Having the edge of the repelling force. Basically what I'm saying is those magnets are not on top of the toroid, they're offset from the toroid, and it's still elevating it. And I believe that this energy is a lot less friction than say being right on top of the magnet. All right, so we're gonna get a sine wave thing. I'm gonna unclip this. We're gonna look at the power supply after I unclip it. All right, let me get the load going.
Yep, it went from 0.9 to 0.7.
instantaneously, right?
Yep.
And the light went back on.
Right.
Going by the bang. So I'd say that's proof right there of something going on.
Yeah, it's yes. Excuse me.
But I haven't been able. There's like this is it. This is the most I've been able to legitimately, stably, function and get it going here. Is the light, and then those 2 amps. Oh, it's going up to 0.8 now. 0.8 now. All right, 0.7. Dang, 0.8. All right, now keep watching that. I'm gonna plug this back in.
Yeah, it definitely changed.
And since each one of these coils is different, and I can see each coil on there pretty much.
Mm-hmm.
Kinda, I guess you can call each one of those differentiations of the wave a coil. You got a little one going up, you got an obtuse one going up, and you got one going down. So, I don't know what that means. It's sweet, and it's awesome. Now, let's see how fast little guy's going. $15.88. Big guy. $15.99.
That's exactly. So if the spikes aren't there, yeah, I see that. Without the downward spikes, then it's just like.
Yeah. Sweet. So about 1600 RPMs with the amps going in with the coil feeding into the system. You've got 1600. Oh, dude, I hit the wrong button. If I'm getting 3,000, that's like twice. Well, I don't know if that's right. Let's see what the big one has to say. Yeah. And it's really like 1.5 amps. Yeah, that little guy was he was like giving me some problems. Alright. So I'm in the market to make about 3 more 26 gauge coils with about 3,000 turns in them. here. And I got cores for all of them. And the 26 gauge coil is going to make enough to, make the light at least that bright. Oh, I know something we can do that's a little different. We're going to, instead of looking at the whole thing, we're just going to look at the BEMF coil sine waves. And then we're going to call it for tonight. Maybe. Pretty sure that's all I got. Alright, so this is the BEMF sine wave. Oh yeah, that's with the light on. But luckily I got a switch, turn it off. That is our BEMF coil. And look at that. That's pretty. Very cool. I like the fact that it's about 100 hertz. I heard a lawnmower outside for a second, but it's just this thing. 1576. Right around 1600 RPMs.
The first one there.
Yeah, that's what he's talking about.
Mm-hmm.
600 volts peak to peak. Wow, that's pretty strong. I'm thinking it's like, looking at it, it is what it is, but that's pretty freaking strong. I mean, considering that all the magnets are facing the same way. Yeah. Wait. I want to put that other rotor out here. Yeah, that one. I'm gonna close out. Oh, look at that. Closing remarks. So you don't get that positive spike without the power being on.
That was still for me.
Alright, so this little bad boy is mean. This one's pretty mean too. I think that this one, even with the toric magnet, is lighter than that one. Alright, man, you want to turn it on? it's going to be a lot weaker because the magnetic field. I'm not really worried about that one spinning right now.
Okay.
Look at the difference in the waves though.
That's all right. We just switched out the rotor from that one to the saucer one. And some nice readings there.
Yeah, those are pretty.
90 hertz.
Yeah, we got 0.5. So I'm gonna. Oh, it's already unplugged. See, there's no. Oh, the lights are off. Let's turn them on. Okay, they're on now. And there's our square wave, or kind of our square wave for the other motor.
And that's with the light on.
Yep. And this one's blinking a lot more than the other one was. Like, the surface area of the magnet over here is way bigger than the surface area here, but the power of that area is like a lot more acute because there's say an inch and a half of north and here there's only half an inch of north, but there's more face of the north. So, you know, I would say that if this got attached to a magnet, it would be harder to pull this one off than that one. If they were the same like length. Well, that's not right. That's not right. It's just, I know that one would be harder to grip, so it's not necessarily true.
Look at it. It's moving the vibration.
Yeah, it's dancing.
Found the spot. Oh, there it goes. This is so cool watching it move to the vibration.
$70 volts. All right. And I try keeping it all cleaned up. I'm gonna keep doing that, I guess. All right, that's all I got for right now. So we've got. So, give me the diagram of the funnel here. You got the open mouth of the funnel. You pour the amps in, as many as you can fit in the top, and then the funnel as it goes down gets smaller. Now, the actual energy or power, as you say, the watts, stays the same. But obviously, as you funnel the amps down, that's going to turn into speed. And these are tiny coils. What's up? up, Kale? Heck yeah, man. All right, so. All right.
Has he seen this work yet?
Well, I don't know. How long you been on, man? Well, how long you been there?
I think he just got here.
Awesome. Awesome. So I got the second rotor spinning. I just used some pendulum magic. It's just a parlor trick. Heck yeah. Awesome. Check this bad boy out. Alright, so we're gonna go right there.
Yeah, I was impressed when I saw it.
That's using the zipper style. Instead of the magnet style, it's the zipper style. All right. So this is how I know you need a rotor.
Yeah, we're working on some magic with that right now. Yes.
Yeah. Yeah. So point 0.7 amps. I'm gonna plug. Let's look. You gotta see this, man. All right, we'll turn our light off. That's what's pumping through the BEMF coil. Oh yeah, man, those are tight. They go so fast. Those VCR rotors. And yeah, some of CD-ROM rotors.
Mhm.
All right, now when I do that, the amps go up on the power supply. When I clip BEMF coil to the coil that's underneath the rotor, I get more amps in the power supply. Yeah, with the light on.
You want to show that one?
Yeah. What I want to show them is put this on the negative. So this one will go here. And then put this one on the positive or this one. Now that is the sine wave for the whole series circuit, all 4 coils. With the power going through it. Now, I just love how the hertz are going up. Out of the wall, you get 60 hertz. Through the transformer, you get a lot more. Alright. So now, we'll hook it back up. I love how this is so much easier to use all of a sudden.
Boom.
No, I'm not getting a reading. Whew, yeah, that was hot. I got a spike. It came on just as, ha ha. Alright, anyway, there it is. That is the coil without the light on. And then there's the coil with the light on. So the square wave, like you said. And I think that was a little bit of atmospherics, dude. I don't think I touched it. Maybe I did. McDonald's way.
Yes, it does. Look at that.
Oh, that's funny. Heck yeah.
Amazing, dude.
Bells. Well, this thing has officially shocked me 3 times today with the BEMF shock. Like, you shouldn't have done that kind of shock. So it's like, whoa, okay, it's getting real. Oh. So, this is a good sign. I'm hoping that I can get, I might have to make it a little bigger, like the one on the bottom, or just not that big, but like not as small as it is. I'll figure it out, and then what I'm going to do is just, the first one, I'm going to have the magnets on the side, but I'm also going to have magnets on the top. So we'll have magnets on both the side and the top. And then the next disc will be elevated slightly and put to the side. So the magnets on the top will turn that one above it. something comes of my thought process. That'd be pretty cool to see that. And I think that I'm gonna make at least 2 more coils like this that I'm gonna replace these 2 with, just to run a non-amp funnel thing, just to make them all, to make them run a uniform. I like the design with 2 offset and 1 onset, or we could do 2 onset and 1 offset, tri-funnel. Yeah, but the cool part about it is that you got to use a 4 magnet rotor. And it's not positioned at 120 degrees. It's not a 120 system. But tri-funnel, definitely I would say that's right. It's a onset offset system. And I don't know, I think the 26 gauge, have them all be 26 might actually work better. And then leaving the toroid magnet coil on the bottom to cap it off would be awesome.
I love that.
It's great.
I love the learning and the teaching. I love it.
Yeah, it's great. It's awesome, man. And you know, we can make great things. And we gotta share them. Gotta share them with the world. My brother's over here like, Adrian!
Yeah. Yeah.
That's really strong. That's 2 N52 stacks on. These are N52s on the little one and on the big one too. So it's like really strong. It's like,
Oh, same here, Kale, and I'm just an observer to this. And it's
I've
quite...
seen was that your latest one? I didn't check when it was came out, but I just saw the one. It was like posted to me. I liked it. I checked it out. It was the simple Hall effect. Is that like using the Hall effect as a switch? Because I wanted to do that. Because that would probably work better than this reed switch. But I don't want to use a transistor. And it's like the cool thing about it is the way it ended up. It goes straight to the funnel, and then this is the drive. And at the end of the drive is the end of the funnel.
Transistor.
Oh, okay. And maybe a transistor would work, just one, maybe. I don't know. I mean, I hooked up one of my M.P.H to this thing. It caught fire. Yeah, it lit up.
Yeah, I'll check it out too.
I haven't been able to make a PMP move anything. I haven't been able to make it move. Probably because I'm hooking it up wrong.
we might need to do like a one-on-one with the voice live somehow, like an X space or even a video or a telephone call.
So Hall effects have to be PMP, is what you're saying.
Yeah, I believe that 100%.
All right. Yeah, because I got a package of them. They're tip 147s.
The thirst mutilator.
All right, so yeah, I just love how quickly this thing picks up speed. I don't know why I can't get my damn coils to jump up the poles anymore. But I found some of the old ones that I used to do that with. And I couldn't make it work. I couldn't make it do it. I couldn't make it do it. Just a single one. I couldn't make it work.
What is a Chinook? Oh, okay. Yep, definitely. I see it.
One of those cargo choppers.
Yeah, and like how it's vibrating the table, even. You can feel both, like, it's a different vibration.
Of the dual.
Yeah. It's more synchronized.
It's only because the bearings are so good.
Mm-hmm. So yeah, you can make the decision. I'm about ready to tap out, but we can put this on a tripod and
No, man, I gotta get going myself.
okay.
But heck yeah.
But we should schedule that up, Gail, because I would be I'll be the cameraman for sure.
Yeah, I need to get those PMPs set up because I know this thing can go a lot faster
Perfect.
than it does.
Zoom would be perfect. Yep. So guys, yeah, hit each other up with that contact info. What up?
Ah! Nice last name. I really like that last name, Angela.
I'll look into that part, but we might have to have.
Angelica. Very good.
We might be able to broadcast the Zoom on YouTube. I'll look into that. Boom! Here, look at what we're doing. Oh, that might have just dropped in and dropped out.
Oh, man, I called her by not her wrong name. Because it was scrolling down too fast.
Email. So yeah, drop. Tell them your email. Or that's what I'm saying.
Well, we both got YouTube accounts. I can drop you a post.
Yeah, you're right. Thanks for saying that. I caught myself there.
I'll send you a message. There's a way we can message on YouTube, right? Like between accounts.
Okay, so that's what
I think there's a way to post. I do.
okay. Yep, we'll get there and then we'll get contact info. We'll figure it out.
Cool.
All right.
Heck yeah, welcome. We're signing off. Peace out.
Have a good night, folks.
Bye now. I'm glad that coil on the bottom doesn't get hot.